Hi everyone, my name is Wei Hao Chong, and this is a joint work with Zhao Hongwang and Wu Mingtu, and the topic is perspective of language sharing scheme in communication systems with graphing. So this is the outline. First I'll introduce the background of this work, then the model assumptions, then I'll explain the perspective of this capitalist and socialist perspective in terms of network management. And then there are two management schemes which is formulated in the optimization framework, and then some properties in this formulation and the conclusion. Recently, the big data applications, and besides of the big data, there are various applications such as voice communications and video communications, and they bring huge data burden to the network. So there is a need to distribute these large data loads across multiple devices or data centers. And the challenge is that we need to distribute the data in a way that they have some kind of benefits, either in terms of the user benefits or the social benefits, or even from the management perspective, the service provider's benefit. So charging and pricing are essential requirements in the operation of a communication network. And then according to the traffic demand and network management setting, it requires suitable bandwidth allocation to individual connection to achieve the QoS level. And there are some prior work talking about this QoS management with various settings and requirements. So, for example, if you are using this voice communication, you actually need a response time in terms of, let's say, milliseconds. Because if you get a long delay, then the voice communication will be going on and off once in a while, and that's not a good call. So, but for some kind of applications, for example, if you're doing this email, and it could tolerate a delay for, let's say, up to a few seconds. And so there are different requirements in terms of different applications. So there are some concerns. So the resource allocation decisions are considered with the allocation of limited bandwidth so as to achieve the best system performance. Because the key is there is a limitations, and that otherwise everybody can use the best quality for all kinds of services. So while it needs to recover cost and make a profit, network managers' economic profit consists of revenue and then minus the cost. And the cost is it has different components. For example, this is the opportunity cost, which is determined through calculating the risk that is caused by blocking connections. So we have two different management schemes which will be introduced. And in the prior work, people have been talking about the management services. So for example, people use this queuing analysis, or they consider congestion pricing mechanism. And also, they have studied a pricing scheme based on connection availability. And there are various work in this area. So I'll skip some of the minor details. So our goal is to introduce the revenue management scheme. And we deal with the problem of dimensioning bandwidth on virtual end-to-end tests. The objective is to determine the amount of bandwidth to serve all traffic demands on the budget constraint. And the relationship between the bandwidth, the blocking probability, and the revenue functions will be determined in this paper. And our assumption is that there is a total connection budget, and then the network manager determines an optimal bandwidth sharing speed to fulfill requirements of connection, and the risk of rejecting connections due to the lack of resources supposed to be kept below a negotiated level. And the risk of blocking possible connections analyzed according to the Erlang formula. That is derived from the queuing theory. And under assumptions of some arrivals and certain time, preset virtual paths and with identical bandwidth, data I for all classes. So the architecture is that we have a network manager, and the network manager manages how much bandwidth is allocated to each class of traffic, and it has to be done under budget. And also there are various classes to be allocated. We assume the user population's internet and connection join the core network according to the Poisson process. So what that means is we have infinite amount of arrival, but they arrive by the Poisson process. They don't arrive all at the same time, otherwise it will just all be rejected. So they just keep coming down and down, and then it follows the Poisson process with some kind of rate lambda. That's the arrival rate. And then connections of class I occur at the source node in accordance with the independent Poisson processes, this rate lambda. And then the sojourn time during which they occupy the path is 1 over mu I. So that's the typical settings for the arrival. And then after some calculations, we can see that the traffic intensity log I of virtual paths can be calculated by this formula. And for each class I in type I, we assume the blocking probability is quite differentiable. And later on we will derive this PI. So the P data I can be derived by this. So that's the blocking probability. And then the expected place occupants, we go through the mathematical details, we are able to obtain this population for the data I. And the trade-off between the efficiency and fairness for sharing bandwidth and computing have been into the network management. So what we mean by two network management perspectives includes the one is for efficiency and the other one is for fairness. So that's the two perspectives. One is the capitalistic and socialistic perspective. So it's just a term that we use. Then what it means is one is to pursue this efficiency, and then the other one has the consideration of this fairness. So in the perspective of a network manager, its profit can be generally formulated by revenue minus cost. But the way they calculate revenue and cost are different. So for this capitalistic network manager, its profit C of data is equal to its revenue minus the cost. Then the components of the profit and the component of the cost is one here. So let's see, for this component, it is the charge for the sojourn time of users on those virtual paths. So in other words, if you have users on your path, then you charge for each unit of time it is on the virtual path. And then the cost is the setup cost for the virtual path. And then the other component of the profit is the admission charge. admission charges, which is charged on the user. And then there are some properties. So for example, this component is an increasing function of the data, which is the reasonable. Because if you're using more bandwidth, then you're going to have more cost. And also by this Turing theory formula, Little's formula, the searching time can be calculated this way. Of course, the effective arrival rate can be calculated as the original arrival rate multiplied by the actual percentage that arrival can be accepted by network, because it has a certain percentage of being rejected, and that part doesn't count as the effective arrival rate. So, and then for another perspective, which is a stochastic network manager, the profit function could be formulated this way, and it's also in the general term of revenue minus cost. But the thing is that for the cost, this part is the same, but for the profit, it calculates the profit in the way that the utility of a specific connection is considered. But that utility function, if it's well defined, if it's defined properly, then there will be some fairness in this setup. So I'll explain an example for this F linear. And here are some properties. So if your F goes up, then your cost goes up. And your blocking probability goes down, then your revenue for the admission goes up, so on and so forth. So here I'll give some probability descriptions. So for probabilistic network manager, the profit function can be expressed in specific for given traffic counts in this way, which is the revenue that you get and multiply some arrival rate from B, so on and so forth. So you get this total profit minus your total cost. And we have some comparisons with firewall. So for the probabilistic manager, its design mechanism is to maximize the revenue multiplied by the weighting, each weighting for each class. And that weighting is between 0 and 1, and it has to be summed up to 1. So that's the total revenue subject to this bandwidth constraints. And the property is that if you are using this management scheme 1, which is a capitalist view, then all the resources are allocated to only one class whose marginal revenue is the largest. So, for example, if we look at the formulation again, and then you see the C function of data I, and if you want to maximize this, actually you take derivative and do it Lagrange, so on and so forth. You'll see that for the marginal cost, for the rate of increase with respect to data I, you choose the largest rate of increase, and then you allocate all the data to that class, and that gives you the maximum. So that's sort of the intuition behind that design, and that gives you this description. So just to make it simple, if you do it this way, then you almost allocate all your resources to a specific class, or even just one or two classes. That gives you the best revenue, and that's not fair. So that's sort of the idea behind the intuition behind this management scheme. And then the other thing is, if you consider this stochastic view, then you'll get different perspectives. So let me just give some slides and show you the utility function. If we look at the design of the utility function, But if we just look at the objective function, actually they look really similar, which is they look just really similar, which is a revenue term minus the cost term. But the thing is, the revenue is calculated differently in this socialistic manager. What it does is, if you do it this way, and you see, if you, let's say you allocate a very few bandwidth to a specific class, let's say you allocate 0.1 or 0.01, a very few bandwidth to that, and what happens is that you take the log term of this, and you get a very large negative number, right? Because it's a logarithmic operation, and that needs that requires a certain amount of the data to be here to make this term positive. So what it means is, if you put very little bandwidth here, then you get negative term, and that negative term gives you a penalty in the objective function. So that's the idea behind this. In other words, if you are doing this, then definitely you are going to allocate a certain amount, at least a certain amount to be here, so that it will give you penalty in the objective function. So that gives you some fairness. And of course, to set the problem up, we also have to just weight the revenue for each class and subject to similar this bandwidth requirements. So if we do this management scheme too, all resources are allocated proportionally to traffic classes. And for socialistic network managers, they can achieve the social welfareness. And the decision makers make their choices on the efficiency fairness trade-off in the revenue management scheme developed by the limited network resources. And we have some description for properties. Let's say if the budget is finite, both physical sets of revenue management scheme 1 and scheme 2, which can be derived from the fact that there exists upper and lower bounds on the bandwidth allocated to each class, and this is true. And then the lower bound is due to the minimum bandwidth requirement of network users, and upper bound results from limited bandwidth. Okay. And we had some derivations on the equilibrium, but it's sort of, I'll just give you the core idea. And in this paper, we studied two revenue management schemes on communication network, which is the socialistic and capitalistic. One is more concerned on the efficiency, and the other one is more concerned with the fairness. And then the two bandwidth sharing perspectives are investigated. And the main contribution is analysis, and there are some more complex relations in the formulation which I just skipped. And the proposed revenue management schemes are investigated through the more complex problems. And due to the limited budget, the profit probability could be viewed as a risk measure that the network service providers cannot provide 100% guarantee availability. That's the problem. And also the analysis of the proposed two management schemes would contribute helpful perspective and managerial insights for network managers while determining bandwidth allocation on their operating network. And in practice, the analysis conducted in this study would be applied to guide development congestion-based pricing for network resources, and then to adjust bandwidth in optimal proportion in response to changes in desired level of modern probability and profit probability. In the future, the verification of proposed two management schemes and real systems or large scale data sets could be conducted to make this work more valuable. Okay, and that's all for my talk. Thank you. Yeah, it's unknown, but it's sort of a subjective view from the operator. So, for example, if a company is operating, let's say, you operate more on the voice communications, then you could put more weight on the voice parts. And let's say you want to focus more on the video communications. For example, you like to provide some kind of multimedia service, then you put more weight on that concept. Right, it's given by the operator. And then for the other, for example, costs, they are calculated maybe based on some accounting rules. So, for example, you want to calculate C, D, and CS. There are some costs, right? And you really need to calculate the facility that you pay for and depreciate it each year. That's sort of the cost that you pay for each unit of time. Right? So it's based on some accounting process.
Based on your perspective,
Right.
which model is being better for the society? Is it based on the capitalist perspective or socialist perspective?
I think that is a very good question, but it's actually subject to your choice or your country's each country's choice. So as you can see in the international politics, each country chooses differently. But if you choose to use a capitalist approach, you get more surplus in terms of the revenues and those benefits. You get total amount to be larger. But you get, of course, the fairness is poor, and then vice versa. If you bring subsidies, then you get more fairness, but the total revenue will be less. But so I don't have a definite answer for that, but it really depends on the choice of your value. Thank you for the question.